Hey besties. So I don't have time for us to go over all of these in depth in class. And I feel like sometimes with proofs, getting the answers to the proof or getting it written out for you sometimes is helpful, but having it explained in words is also helpful too. So I'm going to do that for number 2, 3, 4, and 5. And hopefully you listen to this and I'm not wasting my time. And yeah, sorry for the outburst. Okay, so let's take a look at number 2. We're just going to make this bigger just a little bit so we can plan together. So we want to immediately pay attention to our diagram. We want to pay attention to our proof line. There's a couple of things we kind of want to make sure we're doing and practicing when we are going through and trying to prove things. So our proof line is not always going to look the same. We're not always going to be asked to prove triangles congruent. Maybe we'll be asked to prove sides are congruent. Maybe we'll be asked to prove angles. Maybe we'll be asked to prove why is G a midpoint. Well, those are things that we need to keep in mind. We are not going to be asked to prove the same things. However, the strategy remains the same. We need to be cognizant of how our diagram looks, and we need to be cognizant on what does it take for me to get to that proof line. So we want to start with the end in mind and work our way up, if that makes sense. So we're looking at number 2. And I know that we spoke about Cpctc today. However, it's not always going to be a Cpctc moment. And we have to be careful with that. We don't want to start using that and abusing it when it's not necessary. So we're looking at number 2. And number 2 says to prove that these two triangles are congruent. Now, we already know how to prove triangles congruent. We know that there are only 5 ways to prove triangles congruent. So I'm going to write my 5 ways right up here. So to proving triangles congruent, there are 5 ways. I'm going to say that it's side, 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 angle, side, angle, side, angle, 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 side, and HL. These are my only 5 ways to prove triangles congruent. It doesn't change. Now, we take a look at our diagram. We're proving these two triangles congruent. We have triangle ABD. Triangle ABD is this triangle right here that I'm highlighting in pink, and triangle EBC. Triangle EBC is this triangle here that I'm highlighting in blue. And what I notice is that these two triangles come together and they form some kind of an X. Well, I know as soon as I see an X, I must have vertical angles. So I'm going to mark that immediately. And I'm going to give myself a little note on the side that I have vertical angles. Maybe you'll give your note and you'll mention the vertical angles. Whatever works for you, you want to make sure that you make the note that you need in order to make sure that translates to your proof. So I see that I have vertical angles, and that's something that I'm going to keep in the back of my head because if I need it, I'm going to use it. But my given says that AE bisects DC. So we see this word bisect. And we will always want to draw our arrow to what comes after that. Because unless the language says bisect each other, then we know something's getting cut. Not what comes before the word bisect. It's what comes after the word bisect. So DC is getting cut. DC is this segment right here. I'm going to highlight it in pink. So DC is getting cut into 2 congruent segments. So I have one here and one here. So we have those 2 congruent segments, and I know that angle C is congruent to angle D. So I'm going to mark that. Angle C is congruent to angle D. So I'm going to put 2 arcs here and 2 arcs here. And what do I see? I see 2 angles and an included side. So I know it's not going to be side, side, side. And I know it's not going to be HL. And I also know it's not going to be side, angle, side because I have 2 angles and an included side. And I have to pick between ASA and AAS. And I think I'm going to go ahead with ASA, because that's the only one that makes sense. And I'm going to write my statements and reasons. I'm actually not going to write it here because I'm going to post the answers to this and I just don't want to write twice. But we have a plan for number 2. We spoke about our plan and we have a way that we're going to write our proof. The challenge is to translate your plan into proof writing, and that's only going to get better with time. Do not be discouraged if you are not the best at writing your proofs. We just started this unit last week. You have to practice. So that's that for number 2. We were able to successfully say that triangle ABD is congruent to triangle EBC because of angle, side angle. And stay tuned for the solutions that I'm going to post soon. Now, we are looking at number 3, and we are being asked to prove that WZ is congruent to YZ. That's my proof line. And I need to recall, I can only get congruent sides and congruent angles from congruent triangles. Unless I have something else going on, 9 times out of 10. I don't want to say always because there are some cases where we can get it other ways. But 9 times out of 10, if I'm looking for a congruent side or a congruent angle, I need to get that from congruent triangles. So we see that WZ is this segment right here, and it's a part of this triangle. And YZ is this segment right here, and it's a part of this triangle. So I think we're going to use Cpctc for that. However, before I use Cpctc, I need to first prove that triangle XWZ is congruent to triangle XYZ. And I know that there are only 5 ways that I can do this. So let's list them. Side, side, side. Side, angle, side. Angle, side, angle. Angle, angle, side. And HL, hypotenuse, leg. And I'm going to use my given information in order to prove that these 2 triangles are congruent so that I can end my proof and say that these 2 segments are congruent by Cpctc, which stands for corresponding parts of congruent triangles are congruent. So we are given that angle W and angle Y are right angles, and I know how to mark that. I'm just going to write a little box here and a little box here. And I'm also told that WX is congruent to XY. So I'm going to make a tick here and a tick here. And I've exhausted my givens. There's nothing else for me to mark, and I don't have enough to prove the triangles are congruent. However, I do look for a couple of things. I look for my reflexive, meaning I'm sharing a side. I look for reflexive, meaning I'm sharing an angle. I look for vertical angles, meaning I see an X. I look for, linear pairs. I'm looking for these things, and what I noticed immediately is that these 2 triangles are sharing this side, and I know that because my colors overlap. And if I'm careful, I can see that the sides that they're sharing, well, they look like hypotenuses, because if that's a right angle, the side opposite it is a right angle. So I see that in a hypotenuse and a leg my 2 hypotenuses are congruent and my 2 legs are congruent. So I can say that these 2 triangles are congruent by HL. However, I cannot use HL until I mention, let me write this down, triangles are right triangles. So I know that angle W and angle Y are right angles, but I need to mention that triangle XWZ and triangle XYZ are right triangles. And so that's the statement that I'm going to make. My statement is going to say triangle XWZ and triangle XYZ are right triangles. And the reason that I'm able to make that statement is because any triangle that contains a right angle is a right triangle. Then I can use HL. So after I go ahead and I say that, I use HL and I can end off my proof saying that WZ is congruent to YZ because of Cpctc. And check out the proof for the actual language of the proof. Here, number 4. We're going to go straight to the proof line. And here I'm being asked to prove that triangles are congruent. Well, I'm going to list my options, and that's not going to change. I'm always going to list my options. I don't care how long I've been doing my proofs. I'm always going to list out my options, or I'm going to look at my proof line and I'm going to create a plan. I'm always going to do that because I don't want to make any mistakes. So this is the 5 ways of proving triangles congruent. And I'm looking at this diagram and immediately I see vertical angles. I don't know if I'm going to use it. Maybe, maybe not. But I'm going to mark it either way. And I'm going to give myself a little note that I have vertical angles. So if I need it, I'm going to use it. Then I know that AB is perpendicular. So we see this symbol here. This symbol means perpendicular. Let me write it down so you can see it. Perpendicular. And what I know about perpendicular lines, they form right angles. So if I know that AB, and let me highlight that so you can see a visual. If I know that AB is perpendicular to AD, that's this segment right here, where those two segments meet, that's where the right angle is formed. So I'm going to draw a right angle here at A. Whoops. A right angle here at A and a right angle here, a right angle here at D. So I see that I have 2 right angles, and C is a midpoint of BE. So BE is this segment right here. I need to be very careful. So if C is the midpoint of that, that means that C is cutting that into 2 congruent segments. So based on the diagram that I have, the markings, I see I have 2 right angles, 2 congruent angles, and 2 congruent sides. So I think I'm going to go ahead and say that I'm using angle, side, because that side is not included. However, before I use angle, side, yes, I can mention angle A and angle D are right angles, but I also have to mention that they're congruent. So I can either say that angle A and angle D are right angles because perpendicular lines form right angles, and then make a second step to say that angle A and angle D are congruent to one another because all right angles are congruent. Or I can just make a statement that says angle A is congruent to angle D. And the reason for that is because perpendicular lines form congruent right angles. So whenever you see me writing a proof, I'm always going to do a shortcut because, you know, Miss Heard likes a shortcut. But you do what works for you. In the last one, we are proving that angle G is congruent to angle J. And we want to keep in mind, well, congruent angles will only come from congruent triangles at this point, 9 times out of 10. So angle G is this angle right here. It's a part of this triangle that I'm highlighting in yellow. So ultimately, I want to get this triangle in yellow congruent to this triangle in blue. And in order to do that, I need to get triangle GHI congruent to triangle JIK. And in order to do that, there are only 5 ways. Side, 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 angle, side, angle, side, angle, angle, side, and HL. Now, let's take a look at our given. What we know is that JGH is parallel to IJ. It's already marked, but I'm just going to make the mark a little bit more apparent. So you get 2 things from parallel lines, and this is something that we need to remember. We can either get congruent alternate interior angles. So what that looks like is a Z. So my Z could either be this way or this way. It doesn't matter which way my Z is flipped or switched. It doesn't matter. I can get those. interior or exterior, but usually it's interior. And then I can get congruent corresponding angle. So what does that look like? That looks like, whatever the case may be, we have some kind of transversal, and we have the two angles that are on the same side of the transversal in the same spot. So let's take a look at this example, and I'm going to erase the markings because I really want you to see what's going on here. So what we know is that these two lines, or segments rather, are parallel, which means that this HK must be my transversal. Now, I hope that you can see so far, even if you have to turn your paper, I hope that you can see there's no Z. However, I can say that this angle right here, KIJ, is congruent to this angle right here, IHG, because those are corresponding angles. Just as if we had a diagram that looked like this over here. This is my transversal. These are my two parallel lines. It's on the same side of my parallel line. So we see that they're both on the left side of my parallel line, and they're both on the top of my, on the left side of my transversal line, and on the top of my parallel line. Now, what I know also is that I is the midpoint of KHK. So HK is highlighted in pink. I is my midpoint. So I'm going to say that these two pieces are congruent. Well, I'm looking at my diagram. Sorry, because they were kind enough to mark the diagram for me to say that GH is congruent to JI. So I'm looking at my diagram, and I can immediately tell by the markings that side angle side is where I'm going. So now, if you're the type of person that needs to eliminate as you go, or, as you get more comfortable, maybe you don't have to eliminate. You do what works for you. But I can go ahead, and I know how to write this proof out. I'm going to go ahead and say that these two triangles are congruent because of side angle side. And ultimately, once those triangles are congruent by side angle side, I can say anything about the corresponding parts of those congruent triangles. So I'm going to end my proof off with angle G is congruent to angle J because of Cpctc. So that's all I have for you. I hope that helped. I think I'm going to go over 5 tomorrow in class, but if I don't, at least you have the plan. We spoke through the plan, and I'm going to post the solutions maybe today or tomorrow. I don't know. I don't feel well, so maybe not today. But I will see you guys tomorrow, and good night, besties.